What's up, everybody? Welcome back to the Engineer channel. My name is Tim, the engineer, and today I'm super excited to finally update everyone about what I've been up to for the last 6 weeks, why there hasn't been an upload in 4 weeks, because I've been building to this moment, the moment where the mule prototype design is sort of finalized, but we'll get into that. But more importantly, the technology that I was developing is now patent pending. So you remember in a previous video, I was talking about the fact that while I was developing the mule, or the testing unit that's going to help me get all the data I need for the next gen drone pack, I actually came up with some technology that I didn't want to share with the public because I decided that I wanted to patent it. So that complicated things a little bit because the patenting process is actually fairly complicated in and of itself. The last time I filed for the drone pack patent, it took me 3 years to actually obtain the patent, but you can get some protection by starting the process and sort of locking in your position. I'll do a full video on patents in the future, but what I ended up filing is what's known as a provisional patent. Now, a provisional patent isn't like a normal patent in that it doesn't guarantee you protections. What it does is sort of sets a stake in the ground and gives you 1 year to file the longer 20-year protection of a non-provisional patent. And then it allows you to sort of modify your design on your way to figuring out what exactly you want your claims or sort of your legal argument for your right to that design to be. So again, we'll go into more detail of that in a future video, but today is going to be all about reviewing the design and giving you an update about how I'm doing on the training side. So first things first, let's update there. So I'm down about 10 pounds from maybe 1 or 2 videos ago where I was originally talking about the goal and the mission and my weight. And that leaves me somewhere between 10 and 15 pounds to go to be at my goal weight. I'd be happy being anywhere sort of in that range. And my running performance is starting to benefit from some of that weight loss. So I'm deep into the 6s if I'm running just, sort of like single miles, and I'm in the low 7s on a 5K. And these are not times on flat ground. These are like very hilly elevations that I'm running on. So I'm super happy with how my training is coming along. And I actually entered a local road race over the course of the last couple weeks and placed second for my age group and 5th overall. So not that those results are indicative of my performance in a larger city or definitely against some of the elite athletes. I mean, I'm running like maybe a low tier high school field and track star at the moment, but we're going to be using technology to get me across. But I really wanted to start setting a baseline of athleticism so that way when I combine with the tech, at least my body will be able to keep up. So I know the reason you clicked on this video is because you want to see the design that I've been teasing out for the mule, which is going to help us break the world records for fastest human foot speed, fastest mile, fastest 5K, hopefully. And without further ado, let's go check out the design. Here it is, the design I've been working on for a little bit, which I was previously calling the mule on the channel, but originally that was because we were using it exclusively for testing. And as I've been designing this device, I think that it's actually got some of its own record potential. So I actually think we need a better name for this. And I was thinking about E-RUNR because it's pretty much like an e-bike for running, but I'm not sure if that's what we want to go with. So if you guys have any ideas, definitely drop those down in the comments below. So you might see here, the design is not fully finalized. Previously, when I was working as a mechanical engineer, like when something like this would go to production, you definitely have to have everything super finalized, cannot change because you're working with suppliers and you're needing to make assembly documentation. And while that's great for efficiency, it's not so great for making content. So I've decided that I'm going to leave some of the design elements sort of be determined here once we get all the parts, and then we can work through some of those problems together. And what's really cool is that this frame is entirely made out of aluminum members, which I'll show you a little bit more here about in a minute. But what they allow me to do is really, add things on later so I don't have to worry about hole locations and stuff like that. So you might be wondering, how is this similar to the drone pack? Because they feel like two completely different things. But it's the same because basically the physics at the pin. So the physics at the pin, what I mean by that is that the connection to my body, all my body knows is that I have some forces pushing me in the upward direction and some forces pushing me in the forward direction. So forces in the forward direction come from a powered e-bike rear motor. And basically this device would, without me on it, be capable of like 40 plus miles per hour. So there's plenty of speed to push me forward. And then the other assistance comes from these gas springs, which will be constantly pushing upward and giving me, a removal of sort of my observation of gravity. And so between those two things, I will get sort of the same effect that I would get from a drone pack. And then I've designed in these sensors. You can see these two sensors here, which operate at equal length. And this is the part that I actually wanted to patent as soon as I was designing this apparatus. So what's really special about this, let's go to a top view, is that these sensors here are what are called linear potentiometers. And what they're doing is they're measuring the distance between these 2 points. So if I move left in the operator cavity, then the left side one is going to get shorter and the right side one is going to get longer. Now I'm going to be running an onboard computer that's going to be constantly measuring the differences between these two linear potentiometers and trying to make them the same length. And the way that it's going to do that is by turning these two front wheels. So while this is nowhere near finalized, these two front wheels have these servo motors which are going to actually steer the device. And those servo motors are going to get signals from the computer, which is receiving inputs from the linear potentiometer. So if I move left, the device is going to move left until those linear sensors are showing the same values again. And that's really interesting because that's all only going to require me to run a trigger throttle just to control how fast I'm going. But the device should move underneath me, so that way I don't have to worry about steering it. It's going to almost predict where I'm going and basically just follow along. You also might be wondering what will happen if I fall. And, the details of this, I don't exactly have nailed yet, but I will provide some kind of a bottoming mechanism, whether that's like a mechanical stop or definitely accompanied by some kind of an e-stop. So if like a limit switch will activate if it goes all the way down to the bottom of its travel to tell the motor and everything that it should shut down and I'll come coasting to a stop. And so probably what will happen is I'll, try and lay as flat as I can. And when I bottom out, it'll hold me up from falling all the way to the ground. So that's still in the works, but definitely we'll be developing that together on the channel. And then the last piece is, how is this unit powered? So right now I have this roughly mocked up using power tool batteries. I don't know if I'm going to use like high performance RC car lithium ion batteries or whether I'm going to use sort of like these quick pop in, pop out drill batteries. But either way, it's going to run on a 72 volt system, and that's what's going to power the e-bike motor. And then we'll reduce that down to 12 volts to run some of our equipment on board, like the computer processing all the information from the linear potentiometers. So the whole frame is going to be built out of these aluminum extrusions, which are basically the frame members. And what's special about them is that they have these channels all along each piece. And that allows you to slide in these fasteners, which you can use to attach, cameras, sensors, other pieces of equipment, which are going to make this super modular for us as we continue on the channel, go after new records. We're going to be able to reuse this testing mule for all of our future projects and get more data. Many of the parts you saw in that design have been ordered, but due to the state of the world right now, it'll probably be a few weeks before we actually get them in hand. Luckily, I do have a project we can do in the meantime, which I have all the parts here for, and that's creating a human-machine interface that will allow me to connect to the frame. In a previous video, I showed some of the problems with the existing harness setup, so I've got some decommissioned military gear that we're going to adapt to create a completely new human-machine interface, along with some 3D printed parts. It's going to be really cool. So definitely like this video if you would, please. It helps out the channel so much. Subscribe if you want to see the results of this crazy contraption I'm going to be building in my lab, connecting myself to, and then trying to go as fast as some vehicles go on local roads. It's going to be pretty wild. So definitely looking forward to showing you that in a future video. Until then, onward and upward, and I'm out.
I grew up in a place where they told you what to chase, told you how to run the race. Every move was on the page, but I didn't like their way. Had to fight and misbehave, had to find a way to change, had to leave to find my way. Caught up in a daydream, I beat my mind up.